Good afternoon, everyone. Welcome to Q&I summer course. So today will be your first maths class, and we'll start with the first chapter, that is real numbers. Okay. So let me introduce myself. So students, I am Sunit Kumar. I'll be taking your maths classes, and today is your first lecture, and we'll be starting with real numbers, students. Okay. So let's quickly see that what are the prerequisites which are needed for this. So you should understand division algorithm. So when we say division algorithm, that means, whenever you are dividing one number with another number, so the algorithm says that dividend is equal to divisor into quotient plus of remainder, right? So right? So this is your division algorithm, which you have already studied in your previous grade. So you should know the division algorithm before we start this chapter. Second, you should know how to prime factorize a number. So to find the prime factorization of a number, of a composite number, you should know the method. We'll anyways, recapitulate that in the slides further. And then you should know what HCF and LCM means. We will, again, as I said, we will find HCF and LCM using prime factorization method. And today in the class, I'll also, revise all of those concepts which you have already done in your previous grade. Okay. So what are we going to cover today? So today we are going to do fundamental theorem of arithmetic, which is the first theorem from real numbers, from the chapter real numbers. We'll also learn how to prime factorize a composite number. Then we will try to find HCF and LCM using prime factorization method. Okay. So these are the things which we are going to do today in the class. So first of all, let's understand what fundamental theorem of arithmetic says. So what is the theorem? So theorem 1.1, which is fundamental theorem of arithmetic, it states that every composite number can be expressed or factorized as a product of primes, and this factorization is unique. Means every composite number will be having a unique prime factorization apart from the order in which the prime factor occurs. For example, if I write 6, a unique prime factorization will be 2 to the power 1 into 3 to the power 1. And this can also be written as 3 to the power 1 into 2 to the power 1. So order may be different, but this prime factors and their powers are going to be unique for a particular composite number. Did you understand the basic concept of fundamental theorem of arithmetic, what it states? Is it clear? Jovin, Anshita, Devi Maya. Okay, good. Let's move ahead. So prime factorization of a natural number is unique except for the order of its factors. So its order may change. For example, if we have to find the prime factorization of 12, so this is 2 to the power 2 into 3 to the power 1. Order can be different. We can also write it as 3 to the power 1 into 2 to the power 2, right? But the factors and their powers is going to be same, which is unique for every composite number, right? So prime factorization of a natural number is unique except for the order of its factors. Now, for example, if we factorize 32760, so let's see what its prime factor is. Let's find it out, and we'll also learn how to prime factorize a number, right? So that if you have forgotten it, it will be revised. So 32760. So what do? You start with the smallest smallest prime number. So you divide it by 2. So 2, 16, 38 and 0, 16380, right? Then you will again divide it by 2 because, because its unit digit is 0, it can further be divided by 2. So this is 8190. Again, you divide it by 2. So this is 4, 0, 9 and 5, right? Now this number, this cannot be divided by 2 because it ends with 5. So let's check the divisibility by 3. So for 3, we know that the sum is 9 plus 5, 14 plus 4, 18. So it can be divisible by 3. So when we divide it by 3, we will have 1365. Now let's check 6 plus 5, 11 plus 3, 14 plus 1, 15. It can further be divided by 3. So we can write 455. Now when we divide this further, we know that it cannot be divisible by 3 now because the sum is 14. So because it ends with 5, the unit digit is 5, we'll divide it by 5. So this is 91 and then 7 and 13 and then 13 and 1. So these are the prime factors. So how many times 2? We have 3 2s, 2 3s and then 5, 7 and 13, which you can see here, right? So these are the prime factorization of 32760. Okay, this is an error, right? Forget this. This is of some other number. So 32760 can be written as prime factors as this. So if you write it as powers, so this will be 2 to the power 3 into 3 to the power 2, 5 to the power 1, 7 to the power 1 and 13 to the power 1. Right? So these are the prime factors of this number 32760. Is it clear? I'm sure you must already be knowing about prime factorization. It's just a revision kind of thing so that if at all there is some confusion, that is being dealt with. Right? Let's move to the next slide, students. Right? So once we have decided the order, that let's say we decide that order will be ascending as we did here, we did 2 first, we took 3 after that, and then 5, 7 and 13. So if the order is ascending, then the way the number is factorized will be unique. Then in that case, we say that once the order is fixed, then it is a unique factorization. So that is what is fundamental theorem of arithmetic. Now the first example in your NCERT, if you see, is consider the number 4 raised to the power n, where n is a natural number. Check whether there is any value of n for which 4 raised to the power n ends with digit 0. So we have to check whether 4 raised to the power n ends with 0. So what we are going to do here, 4 raised to the power n can be written as 2 square. 4 can be written as 2 square raised to the power n. Now this can be further written as 2 to the power 2n because power of power gets multiplied. So this 2 and n will get multiplied together and we get 2n, right? Now 2 to the power 2n means 2 into 2 into 2 up to 2n times. You will multiply 2 up to 2n times, you will get 2 to the power 2n. Now for a number for a number to end with 0, it should have at least 1 2 and 1 5 as factors, right? So if a number has to end with 0, it should have at least 2 and 5 as factor, then only you will get 10. 2 into 5, you get 10. So you should have at least one power of 2 and one power of 5, so that you multiply them together and you get 10. So for a number to end with 0, you should have at least power of 2, one power of 2 and one power of 5. Now here what are we seeing? We have only powers of 2. We don't have any power of 5. Now since there is no power of 5, it can never end with 0. Right? So the question was, check whether there is any value of n for which 4 raised to the power n ends with digit 0. So you will write, since there is only 2 as prime factor and not 5, this implies 4 raised to the power n will never end with 0. Is it clear? Is the question clear to everyone? So there is a similar question in exercise that where we have to prove that 6 raised to the power n, whether it ends with 0 or not. So again, in 6 to the power n can be written as 2 into 3 raised to the power n, which is equal to 2 raised to the power n into 3 raised to the power n. Now here you can see here, right? There is no factor of 5 again, and that's why it will never end with 0. Okay, students? So this question is there in exercise 1.1. Right? So this will be similarly solved. Whatever I have written here, you will write the same thing. You will only say that since there is only 2 and 3 as prime factor, and there is no prime factor of 5 here, so that's why 6 to the power n will not end with 0. Okay. So I'll quickly tell you, there is a pop-up which is there in the chat. I'll quickly tell you what that means basically. So in the previous class also, students, I had told you that tomorrow we have a proficiency diagnostic test. So every student needs to attempt that proficiency diagnostic test so that you understand your strength, weaknesses, opportunities, and hurdles basically. So that, we as teachers, we can guide you so that your opportunity areas can be made your strength areas, right? And this will also help us plan this complete summer course, so that after the summer course, when you go to school, you are able to ace there in all the exams which you take. Okay. So tomorrow you will join with the same class link, which we'll be sharing with you again. Every day we are sharing it with you. So you will click on the link, join the class, and then you will log into the platform with the login ID and password, which we'll share with you once you have filled this form. So we would need your email ID, mobile number, so that we can create your login IDs and password, and which you can use to log in on the platform and take that proficiency diagnostic test. Student, this is very important because it will help us benchmark from where to start your classes, what level to start your classes. It's not to test you, but it's an exercise just done so that we understand you more nicely. So currently, because you are online, we are not interacting much, right? So to understand you well, this diagnostic test will help us a lot. Okay. So let's go ahead, students. So this question you have understood, right? Shall I go ahead? Now let's learn how to find HCF and LCM by prime factorization method. So HCF, how do you find HCF? So product of the smallest power of each common prime factor in the number gives you HCF, right? So for example, if we have to find HCF of 12 and 18. So what you will do is you will first of all find the prime factor of 12. So I'm not doing it because this is very easy. 2 to the power 2 into 3 to the power 1. Then what you do, you find the prime factors of 18. So this is 2 to the power 1 into 3 to the power 2. Now what you are going to do, product of smallest power of common prime factors. What are common prime factors? Common prime factor is 2. So HCF of 12 and 18 will be 2. And then product of smallest power of common prime factor. Common prime factor 2. What is the smallest power between 2 to the power 2 and 2 to the power 1? It is 2 to the power 1. And similarly, what is the smallest power of the common factor 3? So it is 3 to the power 1. So the HCF of 12 and 18 will be 6, right? One more thing which you can notice here is HCF of two number is always less than equal to any of these two numbers. So if HCF has been asked, it will be less than 12 and 18. So which can divide, that HCF will be able to divide both these numbers, right? Highest common factor. That means a factor which can divide both these numbers, and it has to be highest such factor. So highest common factor is 6 here for 12 and 18. Is it clear? How to find the HCF? By using prime factorization method. Now what is LCM? LCM is product of the greatest power of each prime factor. Product of greatest power of each prime factor involved in the numbers. So let's say you have to find LCM here of 12 and 18 is equal to greatest power of each prime factor. Here you don't have this common term. Any prime factor, you have to take the greatest power of that. So there are two prime factors here in both the numbers, 2 and 3. So greatest power of 2 in both, if you compare it with both, is 2 to the power 2. This is the greatest power. And greatest power for 3 is again 2. So if you multiply them, you will get 4 into 9, which is equal to 36. Now this is the least common multiple. So one more observation here, 36 will be more than or equal to the numbers 12 and 18. And 36 will be multiple of 12 and 18 both, least common multiple. So 12 multiple, if you write 12 ones are 12, 12 twos are 24, and 12 threes are 36. Similarly, 18 ones are 18 and 18 twos are 36. So the common multiple, if you find, that will be 36, which is the least common multiple. There will be other common multiples as well, but we have to find the least common multiple, and that's why by prime factorization method, we find the LCM to be 36 and HCF to be 6. Is it clear, students? Let's go ahead. Now, this is the first example in your book. We have to find the HCF and LCM of 6 and 20 by prime factorization method. So you can do it on your own. Please do it and let me know the HCF and LCM of 6 and 22 quickly. You can write it in the chat as well. So if you find the prime factor of 6, this is 2 to the power 1 into 3 to the power 1. Prime factor of 20 is equal to 2 to the power 2 into 5 to the power 1. Right? So if you have to find the HCF here, so HCF is highest common factor. So you need to find the common factor. Common factor is 2, and the lowest power of that common factor is 1. So this will be equal to HCF is 2 to the power 1, which is equal to 2.
I have given the answer in the chat box.
Yes, Ansita, it is correct. Now, LCM is, here what you do is all the factors and their highest power. So all the factors. So factor is 2, highest power is 2. 3 has a highest power of 1 and 5 has a highest power of 1. So this is 4 times 3 times 5, which is equal to 60. Okay. So we have what we can see here, HCF is 2 and LCM is 60. Right. So HCF is 2 and LCM is 60. Now, if you calculate here, right, there is one more observation which you can make. If you find the product of HCF and LCM, so HCF was 2 and LCM was 60, the product is 2 into 60, which is equal to 120. Right? And if you find the product of the numbers which were given, so product of numbers, this will be 6 times 20. This is also 120. So what do we observe? That for two numbers, the product of HCF and LCM is equal to product of the numbers. This is another observation, right? But this fact is true only for two numbers. You cannot generalize it for three numbers. For three numbers, this may not be, true. Is it clear? Let's go ahead, students. So just now we were discussing this. For any two positive integers a and b, the HCF of AB and LCM of AB is equal to product of the numbers a into b. Right? This is an important theorem. So product of three numbers is not equal to product of their HCF and LCM. So if you have three numbers, let's say, 15, 20 and 25, if you find the HCF and LCM of these three numbers, the product of these three numbers may not be equal to the product of HCF and LCM. Okay. So this is only valid for two positive integers. Now, next question, we have to find the HCF of 96 and 404 by the prime factorization method and hence find their LCM. So when they are asking you hence find their LCM, that means they want you to use that property where you say that HCF into LCM is product of two numbers. Okay. So if you have to find the HCF of 96, we'll first do a prime factorization of 96, right? So if you factorize 96, 2 times you will get 48, 2 times you will get 24. When you divide it by 2, you have 12. Then again by 2, you have 6. Then by 2, you have 3. And by 3, we have 1. So we can write 96 as 2 to the power 5 into 3 to the power 1. Okay. Now, if you do a prime factorization of 404, so when you divide it by 2, you will get 202. Again, you divide it by 2, you will get 101. Now 101 is a prime number itself. So you will divide it by 101, you will get 1. So the prime factorization of 404 is 2 square into 101 raised to the power 1. Is it clear? So once you have found the prime factorization, you can find the HCF. HCF of 96 and 404 is equal to, the common factor is 2 here, right? The smallest power is 2. So 2 to the power 2, 4 will be the HCF here. Once you have got the HCF, you have to hence find their LCM. This means LCM is product of numbers divided by HCF. So the product of numbers, one number was 96, other was 404, and you have to divide it by HCF, that is 4, right? So when you divide this, we have if you cancel this, you will have 101 into 96. This is 9696. 9696. So this is your LCM. You may have, done it by prime factorization as well. If you find the prime factorization, LCM using prime factorization method, this will be 2 to the power 5, 3 to the power 1 and 101. So if you multiply all of this, you are going to get the same thing. 96 into 101, this will be 9696. Okay. So this value and this value is same. So using this formula, it becomes easier for you as the calculation is lesser. So whenever they are saying hence find their LCM, you will do this. Is it clear, students? Did you understand the concept? When to use this formula? Okay, let's go to the next question. Question is find the HCF and LCM of 672 and 120. Right? So what we are going to do is we are going to prime factorize each of these. So 6 is 2 and 3. 72 if you prime factorize, 2 times 36, 2 times 18, 2 times 9, 3 times 3 and 3 times 1. And similarly 120 if you factorize, 2 times 60, 2 times 30, 2 times 15, 3 times 5, 5 times 1. So if you write the prime factorization, 6 is 2 to the power 1 into 3 to the power 1. 72 is 2 to the power 3, 3 to the power 2. 120 is 2 to the power 3, 3 to the power 1, 5 to the power 1. Right? Now, if you have to find the HCF, HCF will be the common factors and the smallest power. Common factor 2 has a smallest power of 1. Common factor of 3 has a smallest power of 1. 5 is not common, so we'll leave that. So 2 to the power 1 into 3 to the power 1 will be 6. So HCF is 6. If you have to find the LCM, this will be equal to all the factors with the highest power. So factor 2 has a highest power of 3, 3 has a highest power of 2 and 5 has a highest power of 1. So 8 into 9, 72 into 5, this will be 360. So HCF is 6 and LCM is 360. Now, if you are going to check the product HCF into LCM and check the product of 672 and 120, these are not going to be same. So that's why we can safely say that the formula is valid only for 2 numbers. It is not valid for 3 numbers. Is it clear, students? Have you understood the concept? Okay, let's go ahead. Now, here, what you need to do in the first question is express each number as product of its prime factors. So what you will do, you will express 140 as product of prime factors. So prime factorization. So quickly you can do it and let me know one by one. So we'll start with the first question, 140. What is the prime factorization of 140? You guys are typing the answer. I'll start doing. Once you type it, we can. Yes, Ansita, it is correct. So when you divide it by 2, you get 70. If you have done this question, you can move to the next one. Right? Jovin, it is correct for you as well. Devi Maya, it is correct for you as well. So for 2, when you divide 70 by 2, you get 35. Then 5 and 7 and 7 and 1. So 140 can be written as 2 square, 5 to the power 1, 7 to the power 1. So this is your first part. Second part, you have to do it for 156. Yes, Ansita, it is correct. Yes, it is correct, Jovin. So 156 when you divide it by 2, so you get 78. Again by 2 you get 39, 3 and then 13, and 13 and then 1. So 156 can be written as 2 to the power 2, 3 to the power 1, 13 to the power 1. Third part, 3825. So if you see this third one, 3825, we know that it's not divisible by 2. So let's check it for 3. 5 plus 2, 7 plus 8, 15 plus 3, 18. Yes, it is divisible by 3. So we'll divide it by 3. So we have 1275. Again, 7 plus 5, 12 plus 2, 14 plus 1, 15. Again, it is divisible by 3. So 3, 4 times and 425. Now, this is not divisible by 3, but yeah, it ends with 5. So we'll divide it by 5. 85. Again, by 5, we'll get 17. And by 17, we'll get 1. Right? So 3825 can be written as 3 square, 5 square, 17 to the power 1. Yes, correct. So when you write your prime factors, always keep it in mind that it should be in ascending order. Though even if you write it in any order does not matter, but yeah, examiner would like to see it because you are in class 10th. It should be in a proper way. So always write it in ascending order. Okay. So second, third done. Fourth one, 5005. Please try it once. So if you divide it by 5, you have 1001, right? So it was not divisible by 2 and 3. We checked the divisibility rule. Now 1001, let us check it by another prime factor, that is 7. So if you divide it by 7, right? 7 times 1 and 30, 7 fours are 28 and 7 threes are 21. So 143. So this is divisible by 7. Now the next prime factor is 11. Let us check it by 11. 11 times 1. Yes, it is correct, Ansita. Yes, it is correct, Devi Maya, for you as well. Jovin, 1001 can be further factorized. So 11, then we have 13, and 13 we have 1. So you can write this as 5005 is equal to 5 to the power 1, 7 to the power 1, 11 to the power 1, and 13 to the power 1. Correct? Now last one, 7429. This is a bit tricky. Initial prime numbers will not be able to divide it. You check it, it's not divisible by 2, neither by 3, nor by 5, not by 7 also. Check it for 11, 13, 17, and then you will come to a point. So when you divide it by 11, it's not divisible by 11, neither by 13. So when you divide it by 17, right? So 17 4 times is 68, and then 62. 17 threes are 51, and then 11 119. So 17 7 times is 119. Yes, Jovin, it is correct. Devi Maya, it is correct for you as well. So now next by 19 if we do, right? So 19 2 times is 38, and then 57, 19 3 times is 57. 23 is a prime number. So we can write this as 7429 is equal to 17 into 19 into 23. So this is the prime factorization of 7429. Is it clear? Okay. So we'll continue with the solving questions in the next class. So today let's conclude it. So today what did we do? We did fundamental theorem of arithmetic. Then we did prime factorization. We did HCF and LCM, right? So what next? So next class when we meet, we'll complete this whole exercise and we'll learn about irrational numbers. Okay. So thank you students. Thanks for joining in for today's class. Next class will be, in the next week on Monday. Saturday, you will not have a class. Friday, you have a proficiency diagnostic test. So thank you students. Thanks for joining in and hope you liked the class. And if you have liked the class, please subscribe our YouTube channel also, where you will get all the recordings. So if you have missed anything in the previous classes, you will get all the recordings on YouTube. So thank you students. Thanks for joining in. Bye and take care. Have a very nice day.